looking at the sedimentation rates. They weren't really interested so much in the extinction of dinosaurs. They were looking at measuring the rate of sedimentation of deep ocean sediments. One particular little layer, though, however, showed a whopping increase in the concentration of the metal iridium. I mean, they calculated if you were to spread the amount of iridium in this layer, that adds up to a total amount of material about equivalent to a 10-kilometer diameter asteroid.
A 10-kilometer asteroid. That's 6 miles wide, the size of Mount Everest.
The reason why an asteroid was looked at as the cause of the iridium spike at the KT boundary is because asteroids have an enormous amount of iridium in them. The Earth has iridium in it, but because it's a heavy metal, most of it settles towards the center of the planet. But this thick layer of iridium that separates the Cretaceous and Tertiary periods clearly was an anomaly, and it had been deposited over a very short time.
But there was something else that supported the asteroid theory.
Along with the high levels of iridium, they found something even more fascinating. Shocked quartz. Shocked quartz is a form of quartz that has a very different structure. Under incredible pressure, the crystals within the quartz are deformed and actually fractured. Well, under magnification, you can see these deformations.
There was only one other place on Earth where scientists had seen shocked quartz. It was at the site of a nuclear bomb test that was conducted at the Alamogordo test range in New Mexico in 1945.
Shocked quartz was first identified at the site of an underground nuclear bomb test. It's that kind of force that causes this particular quartz to form. So finding shocked quartz mixed within the high levels of iridium was pretty darn clear evidence that something massive had hit the Earth.
How big an asteroid would it take to distribute this much iridium around the entire planet? And they came up with a very rough number of something on the order of 10 kilometers across. That's, it's Mount Everest size sort of impactor, if you will.
But if an asteroid the size of Mount Everest killed the dinosaurs, where was the crater? For 10 years, the mystery remained. Then, in 1990, a new clue. Petroleum companies searching for oil in the Yucatan Peninsula came upon evidence of a massive underwater impact.
There was an oil company in Mexico searching for different places where there might be oil deposits, and in those areas they actually found a fairly circular feature. And in that, they deduced that that might be an impact crater.
The satellite images were mind-boggling.
And then they started to see the telltale signs that something very big and very large had hit. And now finally, what's happened just recent times is we have radar information from the space shuttle. And from that, you can actually see the outlines very faintly of this impact crater.
Today, this huge crater is named the Chicxulub crater. But was it the right size to be linked to the KT boundary evidence?
It wasn't until 1990, 1991 when the Chicxulub crater in northern Yucatan was identified. Most people felt pretty confident that that crater was 180 kilometers across based on the most prominent set of circular features there.
A 180-kilometer crater, that's 111 miles in size. But a question remained. How large would an asteroid have to be to create a crater of that magnitude?
So how big an impactor would it take to make a 180-kilometer diameter crater on the Earth? Well, at the typical speeds that asteroids will strike the Earth, of order 20 kilometers per second, the answer comes back an asteroid, about 10 kilometers across, and that's perfectly consistent with the original estimate from the concentration of iridium that the Alvarez's independently calculated a decade previously.
This evidence was overwhelming. An asteroid about the size of Mount Everest had struck the Earth in the Yucatan Peninsula at the end of the Cretaceous period, 65 million years ago. Then, Dr. William Bottke, Assistant Director of Space Studies at the Southwest Research Institute, went even further. His research pointed to the Baptistina asteroid fragments from the deep space collision 250 million years earlier. And it showed that Earth wasn't Baptistina's only victim. An asteroid also struck the Moon, triggering a landslide.
The Apollo 17 spacecraft landed in a place where they actually detected evidence for a landslide that had happened about 110 million years ago. They believe this landslide was triggered by a cratering event on the other side of the Moon. Not only is it very large, it's well over 80 kilometers or so, but it's also surprisingly young. It would have this age of 110 million years. We find there's a very high probability, well over 70%, that this particular crater was produced by the Baptistina fragments.
An asteroid swarm blasted the solar system. One struck the Moon. Another was on a collision course with prehistoric Earth. The results were horrifying. Traveling at twice the speed of sound, an enormous asteroid made its way into our inner solar system on a collision course with the dinosaurs.
65 million years ago, the Earth suffered an enormous extinction event, one that would wipe out all the non-avian dinosaurs along with millions of other life forms. Imagine a rock the size of Manhattan Island slamming into the Earth at 43,000 miles per hour. You've heard of the phrase hell on Earth. This impact was so powerful, hell would have felt like a tanning booth in comparison.
In 2000, another link was found between the asteroid and prehistoric Earth.
Several years ago, there was surveys that went out and they actually took cores from different places in the ocean. And they tried to probe, to get these cores all the way back to 65 million years ago. And interestingly enough, in one of these core samples, they found a tiny piece of a meteorite, a fossil meteorite. And the composition of that meteorite is very consistent with the composition of Baptistina. So it's not just dynamics, but it's also this link with the chemistry.
The impact of the asteroid would kick off a series of cataclysmic events that would devastate life worldwide. So using science as a guide, is it possible to recreate the final moments of the dinosaurs? The first effect was the impact itself.
So when a 10-kilometer diameter asteroid enters through the atmosphere and impacts the surface of the Earth, you have to realize that 10-kilometer object is comparable to the size, the height scale of the atmosphere itself. And so the object almost effectively never even sees the atmosphere. At that time, a 10-kilometer impactor is going to vaporize, melt, and displace something like well over 10,000 cubic kilometers of the surface of the Earth. You've got 10,000 cubic kilometers of limestone and evaporate and granite being vaporized and excavated and thrown around the planet. It's a hideously violent event, the impact of an object of that size.
The initial impact would have instantaneously vaporized over 72.8 billion tons of solid rock.
You would be able to hear this blast around the world, probably multiple times going around it. We know from human history that when Krakatoa, the great eruption, occurred in Indonesia, that people heard it in the mainland and other parts of Eurasia. And it certainly was detected by barometers all the way around the world. This is something far larger, so you could probably hear this all the way around the world. There may have even been noticeable earthquakes spreading out from it around the world. And then, things would begin to get really weird.
The impact of the asteroid striking the ocean would set off its next form of destruction: tidal waves. But these weren't just any tidal waves. These tsunamis were over 3 miles high.
At the time of the impact site itself was under a shallow sea, a couple hundred feet deep, and so very naturally one of the immediate effects of the impact itself was to launch an enormous tsunami.